Salami Incorporated.
Models and Simulations, Stuart Gray, Chapter 8. My name is Jacob Salmon, and I will be presenting on the aspects of visualization, the positives and negatives of visualization, and the future of visualization in this presentation. Visualization, in its most basic sense, is a graphical output of numeric data generated by the computer models. This allows for the examination of large quantities of data, the exchanging of ideas, and it also allows for the influencing of decision. This is going off of the idea that humans are innately visual learners, and visualization really keys in on this idea. Purpose of visualization is to help make decisions. It allows us to visualize large quantities of data that would otherwise be nonsensible in large tables or large databases. These large databases being very difficult to read patterns and recognize certain analysis aspects. Also allows the ability to explore. Using visualization, we're allowed to actually see into the future to an extent, using assumptions and modeling. Also, we're allowed to communicate information better. As I said before, humans are innately visual learners. Therefore, it allows us to communicate information better. It also allows us to make better decisions. Visualization allows for the analysis of large quantities of data, as I mentioned before. It allows for visual depiction. We can recognize trends and exchange ideas, all ideas I mentioned before. Visualization allows us to explore more thoroughly. It allows us to generate new results and disseminate these results through a large medium. Visualization, a great example is the tracking of hurricanes in Florida. We're allowed to map the trajectory of hurricanes using advanced formulas, physics, and just general assumptions made about the Earth's atmosphere. And we're allowed to disseminate these results using visualization to allow a broader medium to be able to access this data. This allows for the communication of information, visualizing models. It also further disseminates information. Once again, this is a reoccurring fact about visualization. It just allows us to communicate information more easily and effectively. I will be talking about another aspect of visualization later on in the presentation, and the fact that visualization also allows us to generate new results. These results being more advanced and helping to aid in scientific endeavors. Physics. Visualization allows us to analyze physics, as I mentioned before, allows us to generate new results. However, sacrifices have to be made. Ad hoc fallacy. We have to assume certain aspects are going to be consistent throughout the entire experiment. For example, gravity, or the force of gravity on objects in space. Also, this allows for multi-field visualization, which essentially means that we're allowed to use multiple fields in order to express a single idea. We're allowed to incorporate engineering factors, physics factors, and biological factors into the same visualization in order to generate for example, an entire biome or entire climate. However, physics is also in visualization is very time dependent. We have to make a lot of sacrifices. For example, ad hoc fallacy. We can't incorporate every small factor that's going to be affected on the object we're visualizing. Visual abstractions. This is once again going off the ad hoc fallacy, where we have to assume certain factors. A lot of assumptions have to be made. A lot of abstractions have to be determined in order for a visualization to be more efficient. However, this does take away from accuracy, allows for more inaccuracies to be formed when finding new data. So this is a very big issue with visualization. Yeah, going in more detail, accuracy. We fail to represent error and uncertainty in a lot of our visualizations. A lot of people simply draw, for example, a very simple line graph and forget to add error bars where they're needed. This can be a major issue for for presenting data to a mass audience, and they can be ill-informed, essentially. Also, there's major perceptual issues. People can perceive data in different ways, and hence visualization will take these biases into account and can present two visual models on perhaps climate change can be completely different because of these perceptual issues. Also, efficiently utilizing hardware. In today's society, visualization is very undermined, and we fail to use the highest tech to create visualizations. So this can be a very big issue for visualization, especially when it comes to limiting inaccuracies. Also, this human-computer interaction, which goes throughout almost the entire the IT division, where humans and computers tend to be a rational disconnect. Also, global and local visualization. You can focus on one town and its weather, and that could be completely different from the entire weather of the United States, and this can be very affectant on the visualization, essentially the details within context. Integrated problem-solving environments. Visualization allows for these environments to take place. It allows scientists and other people to create visualizations so that other, for example, engineers could use the science behind a visualization of a cell growth, and engineers can use that in creating, I don't know, biomes or creating other simulators. And visualization allows for these integrated problem-solving environments to take place. So integrating scientific and information visualization, this can be this is a small issue. However, it can be intrusive when creating a accurate visualization. Essentially, there's this disconnect between scientific visualization and information visualization. Scientific visualization being that of the visualization of perhaps protons colliding, while information visualization would be more towards businesses. And there's just these underlying ideas within these two divisions. For example, representing error, or how you picture mathematics and the assumptions you make in these two fields. In today's society, visualization is very underplayed, and it can be very affecting of our future. That man right there. And what the big issue here is that visualization can create a lot of new findings in many fields. However, with all these inaccuracies and issues with visualization that are being failed to be represented, it's hard to see a future for visualization without people finally taking these into account when they create visualizations. So there's going to be that major issue that visualization is going to have to face in the future when it comes to its inaccuracies and its integration into multiple fields. We're excited. The first link, iopscience.iop.org, is where most of the information that I received about visualization came from. Also, cs.unc.edu is a dissertation on visualization and its prominent issues. That would be the third link. Check these out if you want to learn more about visualization.
See ya.